So for section 3, we still are solving radical equations. So we're still going to use the steps for solving a radical equation. Right? But the example that we're doing this time is the square root of 3x plus 4 equal to x. So every time we see a square root, our thought should always be isolate. So lucky for us, this is already isolated. So now we can just go to straight to step 2 and raise each side of the equation to a power equal to the index. And when there's no number, the index is 2. Alright, so what we're going to do, since the index is 2, we're going to square both sides. And when we square both sides, this becomes 3x plus 4, and then x squared is just x squared. Right? So now, as you can see, since there's a squared here, then we know that this is a quadratic equation, and the only way to solve for x is to factor. So your question might be, how do we know which side to put all the terms in? So a good rule of thumb is you look at the leading coefficient, so you look at the term with the highest degree, and then you look at its coefficient. In this case, it's 1. If it's so you want the leading coefficient to be positive, and then you know to subtract everything over. So over here, I'm going to subtract these over, so then I'll get 0, and this is x squared minus 3x minus 4. Right? So if you wanted to subtract x squared over, you would just have to divide every term or multiply every term by -1 to make that leading coefficient positive. But I just think it's a lot easier to subtract everything else over. Right? So now that this is set to 0, we can factor this, so we can then use the zero product property. So for a squared, or x squared minus 3x minus 4, so what are two numbers that multiply to be -4 and add to be -3? That would be x minus 4, x plus 1. Right? And so before we move on, we want to check this work to make sure that this is the exact same as the quadratic above. So x times x is x squared, x times 1 is x, -4 times 1 is -4x, x minus 4x, that is -3x, and then -4 times 1 is -4. So this is equivalent. So now we can use the zero product property, and the zero product property states x minus 4. So if we have AB equals to 0, then we know that x minus 4 is equal to 0, or x plus 1 equals 0. Or more generally, if AB equals 0, then A equals 0, or B equals 0. And you could call this A and call this B. Right? So now we're going to solve. So this is x equals 4, or x is equal to -1. So in this example, we have 2 points that we have to check. Right? So I'm going to go off to the side. I'm going to say check. And so for x equals 4, okay, we're going to plug 4 in. So then we'll get the square root. 3 times 4 plus 4. Does this equal 4? 3 times 4 is 12. 12 plus 4 is 16. So does this equal 4? The square root of 16 is 4, and 4 equals 4. So x plus 4 is a solution. Our next one that we have to check is x equal to -1. So plug that in, and when we do that, we get 3 times -1 plus 4. Does this equal -1? Right? If you want, you can still plug all of this in, but one indicator for me that just right away you know that a square root, the principal square root, can never equal a negative number. So we automatically know this is not a solution. Right? But if you don't catch that, that's fine. You could still look. So if you do 3 times -1, that's -3. -3 plus 4 is 1. Does this equal to -1? And when you take the square root of +1, you get 1. So 1 is not equal to -1. So this is not a solution. Right? But if you notice it right away over here, you can stop. So what does that mean? Since x equals -1 is not a solution, our solution is x equals 4.